Good day everyone, my name is Mildred Lafuente, currently taking Bachelor of Science in Business Administration, major in Management Information System. Today I'm going to present my course project, Data Communications and Networking 3. So here, I choose the group 1, which is Introduction to Scaling Networks, LAN Redundancy, and Link Aggregation. So here is the introduction to scaling networks. As today's business grows and so with the technology requirements, a computer network designed to cater and be capable to support the needs for growth is called scalable. First thing to do in properly designed network, the traffic must be controlled and organized so that it doesn't unnecessarily propagate through the network at the cost of bandwidth. Network scalability refers to how well a network can handle sudden changes in workload brought about by sudden spikes or drops in the volume of data it processes. We can achieve this goal through a hierarchical design, which is the access layer, distribution layer, and the core layer. So here we have the access layer. It is responsible in providing a connection to the final users in a local network. Next is the distribution layer. It forwards traffic from or to different local network. Next is the core layer. Core layer is a high-speed backbone of the network between dispersed network. So here in a smaller enterprise networks or corporate networks such as store or small office, core and distribution layers can be combined into a single one, reducing cost and complexity. Even though the hierarchical design model has 3 layers, some smaller network setup might implement a 2-tier hierarchical design, as shown in the photo. Cisco advises this network design principle that divides networks into modular components. So here we have the Cisco Enterprise Architecture. Its modules are Enterprise Campus, Enterprise Edge, Service Provider Edge, and Remote. As shown in the photo, here are the Enterprise Campus, Enterprise Edge, Service Provider Edge, and the Remote. When we say Enterprise Campus, composed of the entire campus infrastructure, they include the 3 layers such as access, distribution, and core layer. In addition to these modules, the Enterprise Campus can be include other sub-modules such as the server, farm, and data center module. This section provides high-speed connectivity and protection for servers. It is critical to provide redundancy, fault tolerance, and security as well. The network management system monitors performance by monitoring device and network availability. Service module. This section provides access to all services such as IP telephony service, wireless controller service, and unified service. The Enterprise Edge, composed of Internet, VPN, and WAN modules connecting the enterprise with the service provider network. This said module extends the enterprise services to remote sites and enables the enterprise to use Internet and partner resources. It gives QoS, policy and reinforcements, and service levels and security. Next, we have the Service Provider Edge. So here, provides Internet, public switch, telephone network or the PSTN, and WAN services. All data enters or exits the Enterprise Composite Network Model or ECNM passes through an edge device. This is the area where all packets can be examined and decision made whether the packet should be allowed on the enterprise network. Intrusion Detection Systems (IDS) and Intrusion Prevention System or IPS can also be configured at the enterprise edge to protect against malicious activity. Next, we have the remote. And now we have the failure domains. A failure domain is the area of the network that is impacted by a problem or failure. The impact of a failure domain is determined by the functionality provided the faulty device. If in case a problem occurs, smaller failure domains reduce the impact of the problem to the whole network, and it simplifies repair and thus decrease downtime. So next we have the fine-tuning routing protocols. When we say fine-tuning routing protocols, routing protocol configuration is usually rather straightforward, though to take full advantage of a protocol's feature set, it is advantageous to adjust the configuration. Link state routing protocols such as Open Shortest Path First, which is here shown in the photo. Single area OSPF is useful in smaller networks. If an area becomes too big, the following issues must be addressed: large routing table, large link state database, frequent SPF algorithm calculations. This work well for large hierarchical network where fast convergence is necessary. OSPF routers establish and maintain neighbor adjacency or adjacencies with other connected OSPF routers. When routers initiate an adjacency with neighbors, an exchange of link state updated begins. Routers reach a full state of adjacency when they have synchronized views on their link state database. With OSPF, link state updates are sent when network changes occur. Additionally, OSPF supports a two-layer hierarchical design or the multi-area OSPF. So now we have the EIGRP, Enhanced Interior Gateway Routing Protocol, another popular routing protocol for larger network. Cisco developed EIGRP as proprietary distance vector routing protocol with enhanced capabilities. EIGRP uses multiple tables to manage the routing process using protocol-dependent modules. Now we have the 5 categories of switches. We have the campus LAN switches, cloud-managed switches, data center switches, service provider switches, and the virtual networking. Now when we say campus LAN switches, to scale network performance in an enterprise LAN, there are core, distribution, access, and compact switches. These switches These switch platforms vary from fanless switches with 8 fixed port to 13 blade switches supporting hundreds of ports. Campus LAN switch platforms include the Cisco 2960, 3560, 3750, 3850, 4500, 6500, and the 6800 series. Next, we have the cloud-managed switches. The Cisco Meraki Cloud-Managed Access switches enable virtual stacking of switches. They monitor and configure thousands of switch ports over the web and without the intervention of on-site IT staff. Next, we have the data center switches. A data center should be built based on switches that promote infrastructure scalability, operational continuity, and transport flexibility. The data center switch platforms include the Cisco Nexus series switches and the Cisco Catalyst 6500 series switches. Next, we have the service provider switches. Service provider switches fall under 2 categories. We have the aggregation switches and the Ethernet access switches. Aggregation switches are carrier-grade Ethernet switches that aggregate traffic at the edge of a network. Service provider Ethernet access switches feature application intelligence, unified services, virtualization, integrated security, and simplified management. Next, we have the virtual networking. Virtual networkings are becoming increasingly virtualized. Cisco Nexus virtual networking switch platforms provide secure multi-tenant services by adding virtualization intelligence technology to the data network center. So here are the switch platforms. Here are the photo as shown. So when selecting switches, So here we have the fixed configuration, modular configuration, stackable configuration. In addition to this, the following list are the other considerations: cost, port density, power, reliability, port speed, frame buffers, and scalability. When selecting the switches, network administrator must determine the switch form factors. So here we have the fixed configuration switches, the stackable configuration switches, and here is the modular configuration switches. Now we have the port density. Port density is the number of ports available on a single switch. High port density switches allow better use of space and power. Next, we have the forwarding rates. So here, forwarding rates define the processing capabilities of a switch by rating how much the data switch can process per second. Which product lines are classified by forwarding rates. Next, we have the multi-layer switching. Multi-layer switches are often deployed in the core and distribution layers for an organization switch network. So here, multi-layer switches are characterized by their ability to build a routing table, support a few routing protocols, and forward IP packets at a rate close to that of layer 2 forwarding. Now we have the router requirements. Routing is an essential component of the distribution layer. Without a routing or process, packets cannot leave the LAN. There are three categories of Cisco routers: the branch routers, network edge routers, and the service provider routers. Routers also come in many factors. Network administrator in an enterprise should be able to support a variety of routers, from a small desktop router to a rack-mounted or blade model. Routers can also be categorized as fixed configuration or modular. With the fixed configuration, the desired router interface are built-in. Modular routers come with multiple slots that allow network administrators to change the interface on the router. So here in the photo, we have the router hardware. These are the routing devices. Next, we have the managing devices. We have the managing iOS files and licensing. Cisco routers and switches come with Cisco iOS software. Network administrators are responsible for managing these devices. This includes initial configuration, verification, and troubleshooting tasks, as well as maintaining up-to-date images and backing up the configuration files. Managing iOS files and licensing. When selecting or upgrading Cisco iOS device, it is important to choose the proper iOS image with the correct feature set and version. iOS refers to the package of routing, switching, security, and other inter-networking technologies integrated into a single multitasking operating system. So next, we have the in-band versus out-of-band management. Regardless of the Cisco iOS network device being implemented, there are two methods of connecting a PC to that network device for configuration and monitoring tasks. So here, as photo shown, now we have the basic router CLI commands. The basic router configuration includes the host name for identification, password for security, assignment of IP address to interfaces for connectivity, and basic routing. So here are the following. So now we're going to LAN redundancy. In LAN redundancy, network redundancy assures network reliability by using multiple physical links between devices provide redundant paths. A network can then continue to operate when a single link or portal has failed. So we have the issue with layer 1 redundancy, which is the MAC database instability. So here, Ethernet frames do not have a time to live attribute or the TTL. Frames continue to propagate between switches endlessly or until a link goes down and breaks the loop, result in MAC database instability. Can occur due to broadcast frames forwarding. If there is more than one path for the frame to be forwarded out, an endless loop can happen. When a loop occurs, it is possible for the MAC address on a switch to constantly change with the updates from the broadcast frames, resulting in a MAC address table instability. So next we have the broadcast storms. So many broadcast frames in a layer 2 loop that uses all available bandwidth and make the network unreachable for legitimate traffic cause a denial of service or DOS and can develop in seconds and bring the network down. Next, we have the duplicate unicast frames. Unicast frames sent onto a loop network can result in duplicate frames arriving at the destination device. Most upper layer protocols are not designed to recognize or cope with duplicate transmission. Layer 2 LAN protocols, such as Ethernet, lacks appropriate mechanism to recognize and terminate endlessly looping frames. Next, we have the spanning tree algorithm introduction. We also have the spanning tree algorithm port rules. Here in port rules, STP uses the spanning tree algorithm to determine which switch port on a network must be put in blocking state to prevent loops from occurring. The STA designates a single switch as the root bridge, uses it as the reference point for all path calculations. All switches participating in STP exchange BPDU frames to determine which switch has the lowest bridge ID or the BID on the network. The switch with the lowest BID automatically becomes the root bridge for the STA calculations. Next, we have the root bridge. Every spanning tree instance has a switch designated as the root bridge referring in this figure. Okay, so the root bridge serves as a reference point for all spanning tree calculations to determine which redundant paths to block. Next, we have the path cost. Path cost: when the root bridge has been elected for the spanning tree instance, the STA starts the process of determining the best paths to the root bridge from all destinations in the broadcast domain. The path information is determined by summing up the individual port costs along the path from destination to the root bridge. Each destination is actually a switch port. So next, we have the extended system ID. The bridge ID or BID is used to determine the root bridge on a network. The BID field of BPDU frame contains three separate fields. We have the bridge priority, extended system ID, and the MAC address. When we say bridge priority, the bridge priority is a configurable value that can be used to influence which switch becomes the root bridge. The switch with the lowest priority, which implies lowest BID, becomes the root bridge because a lower priority value takes precedence. When we say extended system ID, initial implementation of IEEE 802.1d were designed for the networks that did not use VLANs. There was a single common spanning tree across all switches. For this reason, in older Cisco switches, the extended system ID could be omitted in BPDU frames, as VLANs become common for network infrastructure segments. 802.1d was enhanced to include support for VLANs, requiring the VLAN ID to be included in the BPDU frame. So here I'm going to show the LAN redundancy configuration, which I already did in the activity. Now we're going to the link aggregation. Link aggregation is the process of using multiple redundant links as one logical link in order to take advantage of underutilized link to increase bandwidth. So link aggregation is the ability to create one logical link using multiple physical links between two devices. This provides load sharing among the physical links. Link aggregation is the process of using multiple redundant links as one logical link in order to So now we're going for the link aggregation. It is the process of using multiple redundant links as one logical link in order to take advantage of underutilized link to increase bandwidth. So here we have the redundant links with STP. Next we have the advantages of Ether channel. And here in the photo is the Ether channel topology. The advantages of Ether channel, most configuration tasks can be done on the Ether channel interface instead of on each individual port, ensuring configuration consistency throughout the links. There is no need to upgrade the link to a faster and more expensive connection to have extra bandwidth. Ether channel relies on existing switch ports. Load balancing takes place between links that are part of the same Ether channel. Depending on the hardware platform, one or more load balancing methods can be implemented. These methods include source MAC to destination MAC load balancing or source IP to destination IP load balancing across physical links. So we have the Ether channel operation. We have the implementation of restrictions. Ether channel can be implemented by grouping multiple physical ports into one or more logical Ether channel links. The original purpose of Ether channel was to increase speed capability on aggregated links between switches. So we have here the port aggregation protocol or the PAGP. Port aggregation protocol, Ether channel using one of two protocols, PAGP or the LACP, can be formed through negotiation. With similar characteristics, these protocols allowed ports to form a channel through dynamic negotiation with adjoining switches. The PAGP is a 6-scope proprietary protocol that aids in the automatic creation of Ether channel links, as shown in this photo. With similar characteristics, these protocols allow ports to form a channel through dynamic negotiation with adjoining switches. When PAGP identifies matched Ethernet links, it groups the links into an Ether channel. The Ether channel is then added to the spanning tree as a single port. Next, we have the LACP or Link Aggregation Control Protocol. It is a part of an IEEE specification 802.3AD that allows several physical ports to be bundled to form a single logical channel, as shown in this photo. The LACP protocol allows the switch to negotiate an automatic bundle of sending LACP packets to the peer. LACP performs a function similar to PAGP with Cisco Ether channel. Because LACP is an IEEE standard, it can be used to facilitate Ether channels in multi-vendor environments. Now we have the link aggregation configuration. Configuring Ether channel configuration guidelines. We have the Ether channel support, VLAN match, and the range of VLANs. Configuring Ether channel. The Ether channel configuration is simple as long as the network administrator is aware of the limitations. Configuration guidelines. The following guidelines and restrictions are useful for configuration Ether channel. Okay, when we say the Ether channel support, all Ethernet interfaces on all modules must support Ether channel with no requirement that interface be physically contiguous or on the same module. Next is the VLAN match. All interfaces in the Ether channel bundle must be assigned to the same VLAN or be configured as a trunk here. Then next we have the range of VLANs. An Ether channel support the small allowed range of VLANs on all the interfaces in a trunking Ether channel. If the allowed range of VLAN is not the same, the interfaces do not form an Ether channel even when set to auto or desirable mode. As shown in the photo, here is the configuring Ether channel with LACP based on two steps. We have the interface range and the channel group identifier mode active. So here's step 1, configuring the Ether channel with LACP. So the step 1 is specify the interface that compose the Ether channel group using interface range, interface global configuration mode command. The range keyword allows you to select several interfaces and configure them all together. A good practice is to start up by shutting down those interfaces so that any incomplete configuration does not create activity on the link. And the step 2, create the port channel interface with the channel group identifier mode active command in interface range configuration mode. The identifier specifies a channel group number. The mode active keywords identify this as an LACP Ether channel configuration. So here I'm going to show the link aggregation configuration. So here my presentation, and thank you and have a good day.